everyone, Mr. Leonard here. Today we're going to be talking about chemical bonding. You'll need a pen, pencil, something to write with basically, sheet of paper, and of course your periodic table. So make sure they have all those things ready to roll. Now chemical bonding is very important to us because it's dealing with atoms that are combining together. When atoms combine together, they form these things called compounds. Without compounds, we wouldn't have life as we know it here on Earth. So it is very important to us. Two very common examples that we are going to be taking a look at today would be water, which we know is our regular drinking water, or the rain that comes from the sky, or snow or ice, all forms of water, and of course table salt. The thing that we love to put on our french fries and food and things like that. It's also within our bodies. It is necessary for many functions for us to survive. So salt is another important compound or a molecule, as we could think of it if we were talking about one individual merged section of merged atoms. Now there's two ways that compounds can form, and that's through the sharing of electrons or through the transfer of electrons. There's a few other ways, but for the purpose of this class, this is what we're going to be looking at. So first, next to sharing electrons, wherever you wrote that, please write down that this type of bond is called a covalent bond. Now we can think of sharing. So if I have this paper clip, and this hand was one atom and this hand was another atom, we would both use it at the same time. So it's we would both be using this, and then we would stay connected. This is basically what is happening in this water molecule over here. We have hydrogens sharing electrons with oxygen. And remember, the goal of all atoms is to become stable, and they do this by filling their outer energy level. And becoming stable for an atom is becoming happy. So this is what they want to do. In this case, some atoms do this through the sharing of electrons. Now, not all atoms and compounds share electrons. Sometimes they transfer electrons, and that's the second one. This one is called an ionic bond. An ionic bond, you may notice the first three letters, ion. You've heard this word before. These are charged atoms, atoms with positive or negative electrical charges. And the reason why they do that, remember, all ions become stable. So it should be starting to make sense to you as to why some of these compounds are forming. So it's the ions that are passing one or more electrons to another, and when they do that, they fill their outer energy levels. And salt is an example of how this happens. So we're going to take a look at this and see how it works. Okay, to start with salt. As I mentioned, this is an ionic bond. We have chlorine, we have sodium, the two elements that make this up. We have chlorine from the periodic table, sodium from the periodic table. Remember, the first thing that you want to do when you go to draw any atom is write down its numbers of protons, electrons, and neutrons. So we will do that. Okay, let's start with sodium. So sodium is over here. Remember this number, the atomic number, is telling us our number of protons or electrons. Very easy to do. And to find the number of neutrons, we need to take the atomic weight. Sometimes it's called the mass number or the atomic mass, and do a little subtraction with our atomic number. So in this case, I would do 23. I'm going to write a real tiny minus 11. That is equal to 12. So we have sodium all set. Over here for chlorine, again, very similar. This number is telling us our number of protons or electrons, so 17 and 17. Very, very easy. To find our number of neutrons, we need to do a little bit of subtraction. So we have 35 minus 17, and you say, okay, I need to do a little subtraction here and figure all this out. When it's all said and done, it is 18. Okay, so we have our basic information that we need to know for each of these elements. Now let's draw them. For chlorine, I'm just going to draw them right underneath where I wrote this so you can do the same thing. We start with the nucleus, which is the central part of the atom, which contains protons and neutrons. So I'm going to write 17P for 17 protons and 18N for 18 neutrons. And then we need to disperse our electrons as we have before. Remember, the first energy level can hold a maximum of 2 electrons. The second energy level can hold a maximum of 8 electrons. And so far we've used 10. Now if you look at our total number of electrons up here, we have a total of 17, so I have 7 left. So I need to go to the third ring, and I will draw 1, 2, 3, 4, 5, 6, and 7. So we have a total of 17 electrons. This is the correct drawing for chlorine as we've been doing it in class. Now to draw sodium. Sodium, in its nucleus, has 11 protons and 12 neutrons. Very simple. Now let's disperse our electrons. The first energy level can hold a maximum of 2. So we have 11 total electrons. We can't fit all of them there. The second can hold a maximum of 8. So this would put our grand total of electrons right now as 10. 1 extra electron, so I need to go to my third ring. Just barely squeeze it in there. And I'll draw that right here. Now, for sodium to become stable, to become an ion, it needs to get rid of 1 electron. Now remember, getting rid of 1 electron is a lot easier than adding 7. So that's exactly what it does. It actually transfers that electron over to chlorine. For chlorine to become stable, it needs 1 electron. So this is the perfect match. And that's why sodium and chlorine bond together so well. An example of an ionic bond. And these two would now be a salt molecule. So it's a very simple process. And this is how ionic bonding works. So it's the moving of 1 electron over to another. So there you have it. Okay, for our second example, we're going to take a look at water. Now, water, as you know, is composed of 2 hydrogens and 1 oxygen. And you even saw the example in the very first few moments of this podcast. Now, to draw this, it's going to be very, very simple. We need to know 3 things about each element. Okay, I'll just write out our little pen acronym over here, just to keep it easy. Remember, the atomic number tells us our number of protons or electrons, and neutrons is atomic weight minus atomic number. So 1 minus 1 is 0. For oxygen, the atomic number is 8, and that means that we have 8 protons and 8 electrons. And then finally, 16 minus 8 is 8. Alright, to get started, we will draw our nucleus of oxygen, which has 8 protons and 8 neutrons. Very easy. This leaves us to draw our electrons. Now we know that oxygen has 8 electrons. It fills its first energy level very quickly, which leaves us with 6 more to go. So 2 minus 8 is 6. So I'm going to draw these in a slightly different position from where we have drawn them in the past, and you'll see why in a moment. And I'm just going to draw 1 over here and 1 over here, and I'm not going to draw those last 2 in pairs. You'll see why. Now, there's 2 hydrogens to draw, and the reason why water needs 2 hydrogens is because, look, oxygen has 2 places where it wants to share electrons, and you'll see how this works very shortly. The nucleus of a hydrogen is just 1 proton. That's very simple. here we have one electron. Now take a look. These two, I'm going to circle these in a different color. You don't have to do this. But right there, this is where the sharing is occurring. This is the covalent bond. So at this point, the outer energy level for hydrogen is filled. The first energy level can only hold a maximum of 2 anyway. And we are working towards filling the outer energy level for oxygen, which means that we need one more hydrogen atom. So we start with our nucleus, 1p, and then we go to our next, or our only energy level, which can hold a maximum of 2, and hydrogen only has 1 electron. Now, again, these two hydrogens have their outer energy level filled, but they're also filling oxygen's outer energy level all at the same time. So this is our other place where a covalent bond is occurring. So this is why water has 2 hydrogens. If you look at it sideways, so you kind of turn your head sideways, you'll see that it kind of looks like Mickey Mouse. So it's kind of known as the Mickey Mouse molecule, and the reason for that is because of this covalent bonding that is occurring. So it's very neat to see how that works. So there's our water molecule. Looks very similar to our drawing, and looks very good. So that's exactly what we did. Now, the very last thing is to look at the periodic table. The periodic table, we noticed that we drew chlorine and sodium together. All of these, remember, have 1 valence electron, and all of these have 7. So any element from this group loves to bond with elements from this group. The same thing with group 2 and the group with oxygen and sulfur and so on. So these like to bond together ionically. So most ionic bonds are occurring between metals and nonmetals, and covalent bonds can occur between metals or nonmetals as well, or say 2 nonmetals like oxygen and hydrogen, both nonmetals. So they form together to form our water. So there you have it. There's ionic and covalent bonding, the 2 of the most popular ways that compounds are formed.